Right. Example 1. It is simply asked, a bird is flying down vertically towards the surface of water in a pond without moving with a constant speed. There is a fish inside the water. If that fish is exactly vertically below the bird, right? So here it will appear to the fish to be. So who is observing whom here? That you need clarity first.
Fish is observing
Right?
bird.
So here we need to observe fish to the bird here. Is it clear? At the end it is asked, will appear to the fish to be. Bird will appear to the fish to be. Just focus on that sentence. Okay. So let me give that figure presentation. How it is. So here look at a bird is flying vertically down, right? So just below it exactly it hides a fish in the water. So here look at that fish just below the bird, right? Here how that bird will appear to the fish, we don't know. Is it going to observe that bird exactly at same place, or above its actual position, or below its actual position, right? So I am going to assume two conditions here. Okay, because already object is there. If it is observed by the fish at same place, it appeared at same only, right? Okay, so here suppose it is further away than its actual distance, so it will observe the bird above the actual position, right? Here it will be observed. If it is closer than its actual distance, that fish can observe the bird at here below the actual position, closer to that. So here I got all the three conditions: at same place, or above the original place, or below the original place. So closer, far. Okay, then two more options also given here: moving faster than its actual speed, or moving slower than its actual speed, right? So that we need to give clarity here. Which of the four options are true? How can you prove it? So we have to prove which is correct option for this situation. Okay, right? So we'll start here. Where is the object? Here is the object. The original middle bird is the object for the situation given here. Okay, bird is observing that object. So we don't know which is observed by the fish. So that what the fish is observing the bird, that is called as image here. So we have two images here. One is above the and one is below the bird actual position, right? So here simply I am taking the object distance. Always that object distance measured from the interface, right? So interface to the object, that distance I am assuming that unknown value something x. I got the object distance unknown value something x. So here we need to decide image distance, right? For the both conditions I am taking the image distance as same here. Okay, I am not giving any different value for them. Why, sir? Actually they are at different distances. Why you are taking the same distance, right? So here simply we are able to prove y is smaller than the x, or y is equals to x, or y is less than to the x, right? See here I assumed that distances are same here for the far position and closer position, right? If it is observed at here, the distance is x, right? So three possibilities are there. If you are able to prove y is equals to x, what we will comment? That fish will observe the bird at same place. If y is less than x I got, means we will comment that bird will be appear to the fish at a closer distance. If you are able to prove y is greater than x, then we are able to comment bird will appear to the fish at far distance. So remember this, keep this in mind. Okay, na? Right, let me clear this all the information. Then here we need to use plane surface formula, because here you have plane surface. Still water has plane surface, rest almost, right? With the small vibrations in the water also we will consider it is as plane surface, right? So that is why here I am applying a plane surface formula here. Okay, what is that? N2 by V minus N1 by U is equal to 0. N2 by V minus N1 by U is equals to 0. This is our formula. Here what are the N1 and N2 here? N1 is the refractive index of the first medium. N2 is the refractive index of the second medium here. Okay. According to our assumption, where is object? In the rarer medium. It is in the air. Right? Where is the image? It is also in the air. Right? So bird and object above the water level, above the water surface. Right? So here I have to know about object distance and image distance. So what is object distance? This is the object for you, for the fish or anything, right? So the light moves towards the water, then it will be received by the fish, right? Then this fish can imagine that image at certain distance. So that will be called as here image distance. It may be something. I am taken as y for any condition, wherever it may be looking that bird. But finally I am able to give a comment. Is it equal to x, or is it less than x, or is it going to be greater than x? Okay, so that we have to give clarity at the end, right? So here object distance is equal to x, but I am written a minus x. Why? According to the sign convention, right? All the distances should be measured from the interface here. So from the interface, object upward, so you are moving opposite to the incident light ray. So that is why here I took negative for x. Is it clear?
Yes,
Why
sir.
I got here minus? It is according to the sign convention. Then what is image distance? V is equals to, it is y. It may be for the closer bird or far bird, whatever it may be. It is also negative because it is also measured above the water surface, upward. That is against, opposite in the direction of incident light ray, right? Then here write down about the refractive indices. N1 equal to, here it is 1 because bird in which medium? In the air. The light started from the air actually. So where the light started, that you have to consider as first medium here, that is air. Air refractive index is approximately equal to 1. So I am taking here as 1. N equal to 1. Then what about N2? We don't know. So that I am assuming as something N, unknown value. Okay. Then substitute these values in the plane surface formula. Right. So plane surface formula again I am writing here. N2 by V minus N1 by U is equal to. So LHS is that. RHS is becoming 0 or not, we don't know. So we are using the LHS part only. So LHS is written. N2 equal to what here? N. So substitute N2 equal to N. So in the diagram also I have shown that what is N1 and N2. Look at there. Green color N1 just near the object. In the water N2 I represented. So here I substituted N2 equal to N and V equal to minus Y. Minus already we have in the formula as it is written. And N1 equal to 1. Let me substitute that. Then U equal to minus X. So substituted. That equal to, here see the second term. Minus already in the formula. And in the denominator also we have minus. So that minus into minus will become plus. Okay, no? Right. Then first term plus is there. Plus into minus equal to minus. So convey that symbol to the numerator. Actually, there is no requirement of 0 here. Okay. Finally, we will use. Okay. Here, minus n by y. That is, I am taking right side as it is without changing its symbols multiplication. See here, as it is I kept. then it is transposed to the right side. So minus will become plus here. So that is why here I am writing minus n by y is equals to 1 by x with the same symbol minus. Okay, then cancel here, there are symbols, minus minus gets cancelled. Then what is remaining here? N by y is equals to 1 by x. Let me take the cross product here, right? So y into 1, n into x or x into n. So what we will write? Then from this I am able to write y is equals to n into x, right? So what I got? Y is equals to n into x. What is y here? Image distance, right? Is it greater than x? Are you able to say? Or is it equal to x? Or it is less than to x? In this three, which you are going to select here? How do you solve that expression? Y equal to n into x. If you know the n value, we are able to decide y equal to or y greater than to or y less than to x. Yes or no? If n equal to 1, what your expression will be? So let us solve here. Just here it is, I am assuming. Okay. Here, if you are able to see this n value, then you are able to say y is greater than or less than or equal. So here we know what is here pond water. That water highest refractive index is 1.33. It has 1.33. Then object distance, suppose let me take as something x equal to 1. It is in meters or kilometers or centimeters, whatever it may be. Just a unit value I am assigning to the object distance. So here n refractive index of the water 1.33, and I assumed that x value is equal to 1. Then substitute that in the relation what you got, y equal to nx. Then what you are able to answer? Y is equals to 1.33 into 1. That equal to? No, it is 1.33. 1 into 1.33 equal to 1.33. Is it greater than x or not? So what I am able to say here?
N is greater than x.
So n is greater than 1. Automatically y becomes greater than x. Yes or no?
Yes.
Right? So denser medium other than air having the value refractive index is greater than 1 or not?
Yes.
Yes. So automatically always that y value becomes greater or less. Y value becomes always greater here.
Greater.
So which assumption is correct? The bird will appear to closer or far than its actual position. Which is correct?
Far than actual position.
Far. So our assumption I dash is wrong. I dash is wrong. So let me clear that. So this is wrong, right? So what is finally? The fish appears, the bird will be far than its actual position. Is it clear?
Yes, sir.
Yes, sir.
Then, okay, I am able to decide one of the option is correct. What is that? A, B, C, D. Which is correct?
A.
A is correct. Okay, what about B?
Wrong.
Wrong. Then decide which is correct among the C and D options. Moving faster than its actual speed or moving slower than its actual speed. Suppose I am here. I am observing the bird. At the same time, this fish also observing the bird at this place. I am observing at this place. Is it clear?
Sir.
Yes.
Right. So here, just assume this bird reached the water surface. Right? Just it is very close to the water surface. What about its image? Will it remains above the water level or reaches the water level?
Reaches the water level.
Very good. Image also reaches. Both the object and images reaches. Is it clear?
Yes, sir.
Yes.
Yes.
If you get clarity here, next comment about the distances covered by the both. Image traveling y distance, object traveling x distance. We know y is greater than x. Who is covering more displacement within the same time? Within the same time, image covering more distance. Is it clear?
Yes.
Within the same time, both are covering the different distances. If I want to cover more distance within the same time, right, what speed I have to maintain? Same as the bird, or lower than the bird, or greater than the bird? Image is covering more distance. If it want to reach in the same time as the object, what is the speed of the image maintained by here? Is it greater or less? Any confusion? To decide without values? If you are having confusion, suppose bird, speed of the bird is equals to x by t. Yes or no? Speed of the image is equals to what? Same. It's a distance by time. If x equal to 1 and y equal to 1, right, then what about y here? Y equal to n into x.
X.
We know already here. Look at, I got a relation. Using this relation, what I am able to write here, y is equals to n 1.33 into 1. That equal to what? 1.33. So 1.33 by time taken only 1 second. That equal to what I got?
1.33.
So what is the speed of the bird here? Speed of the bird is 1,
1 by
and speed of the image is
1.3133.
1.33. So who is moving faster than its actual speed?
Image.
Image.
Is it clear now?
Yes.
So which of the options among the 4 are correct?
A and C.
Already we are decided A is correct.
C.
Then from the previous explanation you are decided C also correct. Right? If it moves slow, what happens? Give me clarity. If the image is moving slower than its actual speed, what happens? That bird reaches here and the image will remains at a certain height. Am I clear?
Yes, sir.
Yes.
Is it or
Yes,
not?
sir.
Is it possible? Suppose there is a mirror in front of you. If you are placing your hand, what about the image? Image also places the hand against to you, or it remains at certain distance.
Against.
Against to us.
So both
Yes.
coincide, one against the other. Yes or no?
Yes.
So like that you have to assume here. Then only it will give you a clear information. Okay. If you are not assuming, you are unable to answer here because it is a hypothetical question. Yes. So according to that question also, we have to imagine that situations. I think it is clear to you.
Yes.
No more discussion. It is asked once in a essay exam. And last 2021 policy entrance examination also this same question asked. Okay, it is important. Okay, then we will go for example number 2 here. Example 2. What is example 2 here? A transparent sphere of radius r and refractive index n is kept in air. Right? At what distance from the surface of the sphere should a point object be placed on the principal axis so as to form a real image at the same distance from the second surface of the sphere? Did you understand the question? Right? So look at here. What is it? So I am assuming the sphere.
Sphere.
It is 3-dimensional, right? But we are unable to see that 3-dimensional here. Only I am showing you 2-dimensional, right? Okay. So a transparent sphere of radius r. So identify the center, then draw the radius onto the boundary and take that radius as r. So first sentence is completed. Okay, a transparent sphere of radius r and refractive index n is kept. So refractive index of the material is given, medium. Okay, na, that sphere n equal to something. Okay, right. So here let me take a optical axis here, principal axis, right? Optical axis, I said, new word it is. Principal axis also called as or known as sometimes optical axis. Okay, here which object is placed on the principal axis? What is the size of the object? See here, is it visible in the question? Point object is placed on the principal axis from the sphere to obtain real image. So real image forms same side or opposite side? Opposite side. Okay, for example, in case of that magnifying lens, you are able to get the image of sun on the paper. Both are same side, image and object, or opposite sides to the lens? Opposite sides. Okay, na? Image on the paper, object in the sky. Okay, here point object I am going to select here. So I am going to put that object here. Are you able to see? Then
Yes.
we take that object is O. Point object is O. This that object is placed above the principal axis at certain distance from the sphere. Okay. Here to get the image, real image, at least we require 2 rays. Yes or no?
Yes.
Yes. So that should be start from the same point of the object. So here there is no problem because object size is point size. Okay, let me take the distance here. Object distance from the sphere. Here, why I am taking a distance first? Because here mentioned, see, so as to form a real image at this distance, same distance. In the question only we have condition. You see that? So that's why I am assuming the distance first. So this is object distance, right? Then ray started to meet the curved surface at a certain point. Okay, so one of the rays selected. Then it is in the first medium. Refractive index is n1. I am assuming. What is first medium? Where is the object? In the rarer medium or in the denser medium?
Rarer medium.
Which it is, maybe air. Already said here see, kept in air, right? So n1 equal to what we will take? 1.
1.
Okay, then here what is n2? Refractive index of the second medium. It is sphere, right? So here what happens to that incident light ray? It is a transparent material medium, so light enters into the denser medium. Yes or no? Yes, it
Yes.
enters into the denser medium and it refracts. What happens? Here it bends towards the normal or away from the normal?
Towards normal.
So angle decreased. Is it clear or wrong? Angle decreased or
Yes.
not?
Clear.
Decreased.
Yes.
Okay. Then it reached the other surface. Right? It reached the other
Yes.
surface. So there also we need to assume that normal, from there angle increases. So angle increased now. Look at. Right? Then first ray we got on the principal axis. We need one more ray to get the image of that point object. So one more ray is selected. It is passing through the center, so remains undeviate. Are they converging or diverging after refraction? Converging means coincides each other. They are converging. So where they are converging, that point is the point of image. Object image is formed at this point. So let me take that image point as something I. O is the object, I is the image. Then what is the image distance is given in the problem? Same as the object, right? So what the distance may be here? It is also same. How much it is? X, according to the question. So I am understanding the question like this. Is it clear?
Yes.
Sir.
I didn't solve the problem, no solution up to this point. Just only I am given the question explanation in the form of diagram. Is it clear? How to understand the
Yes,
question?
clear.
Right. So
Yes,
now
sir, clear.
let us start solving. So which surface formula is required here?
Curved surface.
Because the sphere is curved surface, right?
Yes.
Maybe different shape but curved. Okay. So what is curved surface formula? N2 by V minus N1 by U is equals to N2 minus N1 by R.
R.
So what is N2 here? Refractive index of the second medium. N1 is refractive index of the first medium. Do you know that values? Yes, we know. Okay, before going that, here look at, to get the image of the object at same distance. Object is here and the distance is x. Image is here and the distance is x. To get exactly, what should I require here? The ray compulsory it is parallel to the principal axis. So this is principal axis and a ray after refraction from the first surface from here. Right? So this is first refraction. Light refracted 2 times. Is it clear? So when it is refracted first time, it is becoming parallel to the principal axis. Am I clear?
Yes.
So here what I am doing here, just I am considering only one refraction. I am not going to observe this second one. Only first part I am observing. So for the first part, can you decide the image distance V is equals to? We are unable to decide because that ray do not converge this undeviate ray. So this is the ray remains undeviate. Do they meet each other? Both are parallel. For any extension, they never meet. So what the distance we are measuring in that condition? V is equals to infinite. Is it clear? If you consider second part, in that condition, where is object? At infinity. U equal to becomes infinity and V equal to x. By taking the second part also, you are able to get image distance or object distance. Right? I think it is clear. Just again think about the concept. Right? So according to our assumption, I am considering only one refraction at the first surface. Right? So where is the object? In the rarer medium called air. Then enters into the denser medium having refractive index N2. Right? Here object distance. What is object distance? X with the negative sign because we are measuring opposite to the incident light ray. From the surface only you have to start. Okay, then next note down image distance V equal to, it is also same. Sorry, for the first surface we assumed that image distance is infinity because the ray becomes parallel to the principal axis. Along the principal axis one more ray we are assumed, undeviate ray. So U I got, V I got. To substitute in the equation, what I required other values here, N2, N1. So what is N1 here? Right? Here N1 is refractive index of the air. It is taken to be 1. What is refractive index of N2? Here already given in your problem is N. Okay, so that is why I taken N1 equal to 1, N2 equal to N. Let me substitute them in the equation here. So V equal to infinity substituted, U equal to minus X substituted, N2 equal to N, N1 equal to 1 and R is R only because there is no change in the radius, given as R only. Then is it possible to solve? In the curved surface formula, what is the value I have given for 1 by infinity equal to? 1 by infinity equal to 0. So N into 0?
0.
0.
Then what is remains here? Only minus 1 by minus x. Minus into minus what?
Plus.
Plus. So here simply look at here. We are writing plus x. Minus into minus became plus here. That is equals to, there is no change in the RHS. N minus 1 by R. Is it okay? See here, I will show you how I got this step. Here, this one I am writing as N into 0. Here minus into minus will be written as plus, because here I know 1 by infinity is equals to 0. Is it clear?
Yes.
Right. So we'll go for the next step. What we required actually, at what distance from the
N2.
object of the sphere should be placed from the surface of the sphere, where you have to place the object. Already we assumed where I have placed it, right? X distance. So I have to find out x equal to. So write the reciprocal for the 1 by x equal to n minus 1 by r. So what it will be written as x equal to r by n minus
1.
both sides reversed. Fractions are reversed. It is not a problem. Both sides if you are reversing. That is only called as reciprocal. Okay, na? Right? Reciprocal means reversing the fraction. Either sides. Okay? Right. So I got x equal to r by n minus 1. So this is the object position. Right? So therefore object must be placed on the principal axis from the first surface is x equal to 1 by r by n minus 1. Any confusion in this
No.
or anybody else? Nothing to ask? Is it clear? If it is clear, I will go for the next example. Okay, shall we start next example?